Hello, everybody. My name is Jeff. I'm founder at Numina, and we work on a lot of things at Numina, but one of the things we work on is scaling up distributed inference and test time compute. And I think of all the things we're working on, it's the thing that I am the most excited about. One of the things that we kind of ground ourselves with at Numina is we're trying to democratize intelligence for the permanent underclass. And the only way to do that is to break the oligopolistic centralized infrastructure of the big labs and build a world-class frontier distributed infrastructure to do that. Now, when I think about the tools that I use every day that I couldn't live without, it's things like deep research and very recently Cloud Code, my entire engineering team right now. And those are really an interesting system of different models working together in tandem. But the biggest wins come from reasoning and agents and agentic workflows. And the biggest thing that we can see from there is there's incredible gains to be made from these pre-trained bases. There's so much intelligence in there, and we're really not getting that much out of it. These giant models have so much to give, and when you let them think about it and you let them actually reason, you can get some unreasonably good results. But so far, those are hidden behind kind of APIs where the best we get is O3 mini high, where some unspecified set of additional reasoning goes on behind the scenes, and you don't get to see the tokens, you don't get to understand what's going on, and even though you pay for them, and you just have to pinky promise that it's really happening back there. But we see the performance gains, you see the benchmark results, and the kind of working with these models, it's very easy to tell that a different paradigm is happening. Now you enter R1, which is a schizo model in the chain of thought, but man, is it good at math. It is so good at math, and it's so fun and interesting to talk to. But it doesn't use the reasoning traces. It spools them out in memory. You've got a whole bunch of really interesting context that you can reason about what's going on, but it's really not making the best use of all those flops it possibly could. Now, while we're on the topic of R1 and DeepSeek in general, they did such an incredible thing with the 5 days of open source, but the thing that was most interesting to me was they made everyone believe it was possible to compete with the big labs at a reasonable level. And they made everyone believe, and they made everyone take notice, and I think that was one of the last missing pieces to say, hey, distributed inference can actually work. You can actually challenge the existing systems and do it without spending $1 trillion on a single building. And one of the things that was most interesting about the last release was they said, we understand the limitations that we're working with, the constraints, and it's really like working in a bit of a distributed system. They said no tensor parallel anywhere, and we're going to hill climb that goal, and we're not going to allow ourselves to do any cross communication. And they fucking did it, which is insane. The new system, the V3 architecture in R1, has virtually no cross communication. It is all north-south. And when you think about, well, what would you need to actually build a world-class, frontier-level distributed inference infrastructure? It's, well, cross-communication over WAN sucks. But now you look at some of the other things they did with load balancing their experts and how they understood, based on the load, co-locating experts in specific ways so that you minimize cross-expert communication, and then actually moving experts on different GPUs to balance them. They did amazing things by saying, hey, there's going to be a ton of latency in the system, so how do we smartly trade off the async latency, network latency, for saying, when I have network latency, chew on your compute. When I have network free, do all of our communication. These are all the basic systems that would be required to build a distributed MO over WAN. However, there's a lot more required to do that. You have to understand geographic load balancing. You have to understand distributed KV caches. You have to understand how to route during failovers. You have to have trusted compute. If you're going to put all these different systems in, you have to understand how to at least encrypt the systems over, which adds latency and overhead, or you have to understand things like trusted execution environments with systems like Intel TDX and the H100's confidential compute enclaves. We've gotten all of these parts with the open source release of their weights, with the architecture, with the funding, to actually build a reasonable frontier-level distributed inference system. But then what can we do with that? It's great that we have it, but DeepSeek exists as an API right now that's not very interesting, that we could just spread it out. I mean, maybe it is, technically, but not practically. Well, what if we stuck real test-time compute to make those chains of thoughts very useful? What if we could do the O3 style best of n mixed with tree search? What if we could actually tree search out to all sorts of nodes, thousands and thousands of nodes on a single job? What if we could specify validators and verifiers to build mu0 style tree searches on inference with different types of optimization policies? What if we could build systems that the big labs never could, based on scale, based on their targets, based on what they are incentivized to do, both from product and infrastructure systems? What if we could actually take the distributed inference system and turn it to an advantage to compete with the big labs in a way that they could never compete with otherwise? And that's one of the things that we're working on really hard, but it's something that everybody should be working on. If you stitch on top of that real tree search, real entropy-based sampling, real best of n, in being able to allow these systems to think for minutes, hours, days, you can actually control how long it thinks. Nobody tells you how much budget you can put in this. If you have a really hard problem, let Jesus take the wheel and let him go. Now you have the ability to do that with test-time compute in a way that would never be practical or economically feasible for the big labs. But this is how you get the best tokens. This is how we can turn the distributed inference system into a huge advantage. Now imagine that you could use Claude Code, but with a fleet of little Claude codes working on highly specified problems where you allowed them to loop in these distributed inference environments where they could reason. And they could reason on the entire Git chain. They could reason on the CI test. They could reason on specifications. They could reason on protocol specifics. They could reason on test infrastructures. And then your human-in-the-loop teams are the validators and the verifiers inside your tree search, inside your search systems and validation systems. And you turn around and you take all that data, and you put that as a gRPO or a PPO, and now you start building these end-to-end agent systems. Now you have this distributed inference system not only competing on the best quality tokens on a per token basis, but you're training it to be better with the aggregated experience of all these different systems. We're working on a lot of other stuff, and it's a lot of really complicated things to make that a reality. There's a lot of really tough problems that you have to solve, both economically and from a coordination standpoint. But I really think that this is the first time where we can sit on the precipice and say, test-time compute, distributed inference can reasonably compete with the frontier and do it in a way that they could never do it. And I'm very excited to be working on it. Okay.